Hi guys, welcome back to Algebra 1. Today's lesson is over solving literal equations. So here's your learning objective for the video. Students will be able to solve a literal equation with multiple unique variables for any one of those variables. Now you're probably asking, what is a literal equation? Well, a literal equation is any equation that has more than one unique variable. Unique basically means different. So if you look at these three equations I have below, which ones have more than one unique variable? If I look at the first equation, I see y and I see x. That's two, so that's two unique variables. That means that is a literal equation. The second one has p, l, and w. Those are all different and there are three of them. Means that one is also a literal equation. The last one has x and x. Well, it has two variables, but they're not different. That means they're not unique. So this one is technically not a literal equation. Now the question becomes, how do we solve a literal equation? Well, this works very much the same way as a normal equation works. Whatever we're trying to solve for, we're going to get it by itself on one side of the equal sign. We're going to do that by getting rid of any fractions first, then distributing if we see parentheses. Then we're going to move terms from one side to the other so that what we want to have by itself is by itself. And last, we're going to either multiply or divide to get rid of the coefficient. So here's example 1, and we're being asked to solve for the variable w. So we start the same way we'd start before. We draw our line. Now there's no fractions here, there's no distribution, so we move on to identifying the terms. All three terms get a box because all three are variables, but I put them in different colors to indicate that they are different variables and they are not the same. So I want to get this blue box, this 2w by itself, so I have to move the green box that has 2l in it. So I take away 2l from both sides, and I'm left with p minus 2l equals 2w. So now my blue box is by itself. Now I've got to worry about getting rid of the 2. Well, the 2 is being multiplied by w, so I do the opposite of that, which is divide. And I don't just divide that by 2, I divide everything by 2. So my final answer is p over 2 minus l equals w. And the reason that l doesn't have a 2 anymore is because the 2's cancel each other out. Very much the same way that the 2's cancel each other out here in front of the w. So the final answer is w equals p over 2 minus l. Example 2. We want to take this equation and we want to solve it for r. So I start by drawing my line. And then in this case, there's no fractions or decimals still, or distribution. So I'm not going to clear anything or distribute. So I move on to identifying the terms. Now it's obvious why C gets its own shape, its own color, but it's not quite so obvious why 2 pi r, the entire thing, gets its own shape as well. Well, 2 and pi and r aren't separated by pluses or minuses, which means they're all part of the same term. So they go inside of the same shape. Basically, 2 and pi are the coefficients of r. So let's go ahead and let's get rid of them one at a time. Let's get rid of the 2 first. And I just said it's the coefficient, which means it's being multiplied by r. So we're going to divide both sides by 2, and that gets rid of the 2 on the right-hand side. I also have to get rid of the pi so that r is completely by itself. So just like before, I'm going to divide both sides by pi. When I do that, I get r all by itself here on the right-hand side. So the final answer is r is equal to c divided by 2 pi. Example number 3. I want to take this equation and solve it for y. So I start off and I don't see any fractions here, so I don't have to clear anything, but I do need to distribute. So let's distribute on that right-hand side. I get 2x plus 12 on the right-hand side, and as you can see, I've already drawn the shapes. Now, if you remember from before, variables always get boxes. That's why y and 2x get boxes. And constants get circles. That's why negative 5 and positive 12 have circles around them. Now I want to get y by itself, so I'm going to have to move the 5. So I add 5 to both sides. I get y is equal to 2x plus 17. And as you can see, y is all by itself, which means we have correctly solved for y. Y is equal to 2x plus 17. Example 4. In this case, I see distribution and I see a fraction. So let's take care of that fraction first. In order to clear a fraction, I have to multiply the entire equation by a common multiple of the denominators. In this case, I only have one denominator, which is 4. So this one's pretty easy. I just multiply everything by 4. Now when I multiply everything by 4, I only multiply the things that are outside of parentheses by 4. I don't multiply the things inside the parentheses by 4. So in this case, I'm only going to multiply the 2 and the 5/4 by 4. So what I'm left with is 8 times the quantity y minus 3 equals 5 times the quantity x plus 8. What I'm left with is distribution. I distribute on both sides. I get 8y minus 24 equals 5x plus 40. And then I draw my shapes. So 8y and 5x get squares. Negative 24 and positive 40 get circles. I want to get the red square by itself first, so I have to move the 24. So I do plus 24 to both sides. And then I get rid of the 8. It's the coefficient, so I'm either going to multiply or divide. In this case, I'm going to divide both sides by 8. The 8's in front of the y cancel out, so I'm left with just y. 64 over 8 divides out and becomes 8. And 5x divided by 8 doesn't reduce, so I leave it 5/8 x. So the equation solved for y is y equals 5/8 x plus 8. So that's the end of our video. At this point, you should be able to solve a literal equation with multiple unique variables for any one of those variables.